Let's study 9th Standard ICSE Physics Chapter 1C, the sums of a simple pendulum. Exercise 1C, numericals. The first one. A simple pendulum completes 40 oscillations in 1 minute, that's in 60 seconds. What is its frequency and the time period? Frequency is number of oscillations per time. That's 40 upon 60, that's 0.67 Hertz. This is a rounded off value. Time period is the reciprocal of frequency, and frequency was 40 upon 60, so the reciprocal of that is 60 upon 40, so we get the answer as 1.5 seconds. Do not take the reciprocal of this value because this is a rounded off value. Next, the third sum. Mark this as IMP. The seconds pendulum is taken to a place where acceleration due to gravity falls to 1/4. So value of g decreases. How is the time period of the pendulum affected at all? Well, if the value of g decreases, time period will increase. That means the pendulum will take more time to complete an oscillation. And that means that time will slow down in that clock. Give reason and what will be its new time period. Well, we know that time period is inversely proportional to the square root of g. After all, the formula is time period is equal to 2 pi square root L upon g. So if the length is constant and 2 pi is constant, so definitely time period and acceleration due to gravity, or the square root of that, are inversely proportional. As the value of g decreases, the value of t will increase. But by how much? Well, if the value of g becomes 1/4, don't think that the time period will quadruple. Since there is a square root involved, what's the square root of 1/4? That's half. So that means time period will simply double. So since g becomes 1/4, time period becomes double. If g would have become 1/9, time period would have been tripled. If g would have doubled, that doesn't mean the time period would have doubled because there's a square root involved. So keep that in mind. So the new time period is the old time period into 2. That's 4 seconds. But how is the old time period 2 seconds? Well, in the question they mentioned it's a seconds pendulum. So on Earth, the seconds pendulum's time period is always 2 seconds. Next, the fourth sum. Find the length of the seconds pendulum at a place where the value of g is given, and here even the value of pi is given. So we won't take it as 22 upon 7, and g has been rounded off to 10, not 9.8. So the formula, substitute the values of g and t and pi. But how did we get this formula? First we did squaring both the sides to get rid of the square root sign. Then I want L alone. So g went up and 2 pi went down. Another way of writing this formula was like this. T squared is equal to 4 pi squared L upon g. So g goes up and 4 pi squared goes down. That's how we got this formula. Value of g given. Time period for a seconds pendulum is 2 seconds. Pi's value given. This and this cut. And this upon this. 3.14 squared is almost equal to 10. That means the answer will be very close to 1 meters. In fact, it is exactly 1.01 meters. We have to solve up to 2 decimal places. That's sufficient. Compare this with the solved example number 1, where we took the value of g as 9.8 and the answer came to 0.99 meters. So no need to do the entire calculation. You can simply remember that whenever the value of g is 9.8, then the length will be 0.99, but the value of g being 10, then the answer comes as 1.01. This is assuming that the time period is 2, by the way. Only then this trick would work. Next, the fifth question. Compare the time periods when the lengths are given of the pendulum. Whenever they ask for a comparison, that means they've asked for a ratio. So remember, time period is directly proportional to square root of length. More the length of the pendulum, more is the time period. That means slower it will work. So the ratio T1 upon T2 is equal to ratio of square root of L1 upon L2. But L1 upon L2 is given 1 upon 9. So the answer is 1:3. Don't forget to write the final answer as a ratio and not a fraction. And you should write the final statement also. So the ratio of the two time periods is 1:3. Similarly, in the seventh question, the time periods ratio is given and they've asked for the ratio of their lengths. So again, since time period is directly proportional to square root of length, so T1 upon T2 is equal to square root of L1 upon L2. Now, squaring both the sides, we get T1 squared upon T2 squared is equal to L1 upon L2. Substitute the values of T1 upon T2 as 2 upon 1, and we get the final answer as 4:1. Make sure you write the statement in the end. Now let me give you a hint for the 8th sum, which is for homework, along with the other sums. And note that the 4th sum was IMP as well. Mark it. Now it takes 0.2 seconds for a pendulum bob to move from the mean position to one end. So how many oscillations is this? See, an oscillation is from the mean position, you have to go to one extreme position, then go back to the other extreme position, and come back to the mean position. That's called one oscillation. But here, it is from mean position to one end. That's it. So I reckon this is just 1/4 of an oscillation. So now you can solve this sum.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.